Hello everyone, welcome back to the channel. If you are new here, I am so happy to have you with us for this brand new series, and I promise to be with you from the very first video all the way to the last one. So today we are starting from the absolute foundation, so let's jump right into it. If you are using JMeter just to record user clicks and click the run button, you are using it completely wrong and you are probably crashing your computer. Welcome to video 1 of our complete performance testing series. Today we are breaking down the real JMeter architecture based on the official Apache JMeter documentation. This will help you understand how professional engineers simulate thousands of global users without running out of memory. So to understand JMeter, the first thing you must know is that JMeter is not a web browser. When you open Google Chrome or Safari, the browser downloads HTML, reads CSS, runs heavy JavaScript frameworks, and builds the visual page on your screen. So JMeter does none of that. It works entirely at the protocol layer. So it only sends raw requests over the network and measures how many milliseconds it takes to get the raw response back. Because it does not waste the CPU or memory rendering graphics or running client-side scripts, one single machine can simulate hundreds of virtual users at the same time. This simulation runs on the Java thread engine, and inside JMeter, every single virtual user you want to test is a separate Java thread. When you configure your workload, you are telling the JVM or the Java virtual machine to create these parallel execution lines. If you have 100 threads running, you have 100 virtual users executing your test components one after another. Each thread runs completely independently, running its requests in a continuous loop based on your settings. According to the official JMeter documentation, Apache JMeter component reference guide, these elements always execute in strict order, no matter where you place them visually in your tree in the test plan. First, the configuration elements like HTTP request defaults set up the basic settings. Next, preprocessors modify the requests before they leave your machine. Then comes the timers, which add realistic delays between actions. After that timers, the sampler itself, like an HTTP request or a JDBC database query, actually fires the data packet over the network. Once the server responds, post-processors extract dynamic data like login tokens, and assertions immediately check if the response code and data are correct. Finally, listeners collect the performance data. This brings us to the biggest memory trap in performance testing, which is using visual UI listeners. Components like the view results tree and graph results are great for debugging your scripts with 1 or 2 users, but they consume huge amounts of Java heap memory because they store every single request and response string directly in your RAM in the memory. If you run a heavy load test with these active, the JVM or the Java virtual machine will throw an out-of-memory error and crash your test application. To avoid this, production performance engineering requires running completely headless through the command line CLI mode using the -n and -t flags. This completely bypasses the graphical user interface and saves all metrics to a lightweight log file. Now that you know how the underlying thread architecture works and how elements execute at the protocol layer, we need to learn how to properly manage these virtual users. In the next video, we are diving deep into thread groups to map out realistic user workflows, ramp-up strategies, and test durations. without triggering false server errors. So hit that subscribe button for QA and dev tips so you don't miss a single video in this framework series, and let me know in the comments what kind of application you are planning to load test first.